So this is the notation you have to be aware of. It's all based on your end behavior. Okay? Whether it's y equals or f of x equals, it shouldn't make any difference to us. Does everybody feel okay with that? I don't want that to be a sticking point on the quiz tomorrow, so I want you to be sure this makes sense to you. Everything in blue is what you're going to get. And then in red, you're going to show me on the graph what it looks like on the graph for end behavior, and then describe what the f of x behavior would be on the graph.
Will we get marked down a point if we don't have the list?
No, I'm not going to mark you down a point. Why don't you want to make the list? Do you have texting to do? What is it?
No, I was just wondering.
I don't know how you're going to do this without somehow thinking about that list.
Right.
I'm going to tell you over and over and over again, whenever we talk about graphing, make the list, make the list, make the list. It shouldn't even, it's going to be something that's second nature to you. So don't think you're doing yourself every time you say, oh, I'm just not going to show this, you should have that person in the back of your head going like this. And you should be, what? Show everything.
Okay.
Let's say you show this, and you make a mistake with this or this. Then I can give you credit.
Okay.
But if you don't have that, I can't help you. And I can tell you from experience, the people who aren't making the lists, they're either here again, or they will be here again. Don't take shortcuts. You're not doing yourself a favor. Okay. Right. Everybody feel good about this? How about synthetic division? Is everyone comfortable with that? That's what today is going to be based on. If you're good with synthetic, today is going to answer some questions as to what the heck are we doing synthetic division, direct substitution stuff for? Why are we doing it? How does it help us? Okay. Anybody have a question on synthetic before we go charging in here?
That's going to be good, right?
Uh-huh.
So where are we going to find out today why if x is the end component equals x equals?
I don't know. We're going to do some stuff today. Let's not try to steal my thunder.
So we're going to find.
Pretend like it's a book and you don't know the end. It's going to be a surprise today. Yeah, don't be telling me that you want to know that you're the last page reader before you start the beginning of the book. We don't want that either. Jeez. Okay, we're going to look at a couple things. We're going to look at polynomial long division. And polynomial long division, you have to be able to handle that because not everything can be done synthetically. So there are times where you're not going to have a choice, and we'll look at those first. Okay? And really those are a pain, and I'll show you exactly when you have to use them. It's easy to spot. It's not an option. Okay? We're going to then talk about how can you divide and when can you divide polynomials synthetically. And then we're going to talk about, if you can, how does the remainder in the factor theorem help us? Okay? How does the remainder in the factor theorem help us? Okay? So we'll first go back to 4th, 5th grade when you did long division. Okay? The thing on the outside is called the divisor. The thing on the inside is called the dividend. And the answer is called your quotient. Okay? 324 divided by 4. Well, when you do long division, for example, 4 goes into 3245. If we're going to do long division on that, you would say 4 goes into 3, and it doesn't go. 4 goes into 32, how many times?
8.
You write the 8 here, then what do? Multiply, write it down, draw a line, and subtract. When you subtract, you don't have anything come out nice. 4 goes into 4 once. 4, subtract, you get a 5. 4 goes into 5 once. 4, subtract. What's this thing called? That's your remainder. Okay? And yeah, in 4th grade, you used to put R1. And if you have the crazy psycho teacher, you had to put R period 1. Okay, and if there was no period, minus. Not going to have that. Okay, what did you learn to do with that 1 after a while? You could add a 0 and put a decimal point and keep going. But before you did that, they taught you something else.
Put in the fraction you have on the left side of the calculation.
I want to know what they taught you to do with the 1. What did they teach you to do with the 1? No, you can't just throw it away. No, wait, we got extra stuff. Let's throw it in the trash. It'll be okay. Can't do that. Come on, we're dividing. We got 811. You said you got a remainder of 1. Yeah, you put the 1 over the divisor. So you got 811 and 1/4. Remember, this is the quotient. Right here, that's the quotient. Bless you. This 1 right here is your remainder. And that 4 is your divisor. All right? And what we're going to do when we divide one function by another is we're going to write the quotient. And instead of writing 811 and a 4th, we could say it's 811 plus a 4. And that's how we're going to deal with this. You're going to take your remainder over the divisor. And that's how you'll be writing your answer. So it'll be quotient plus remainder over divisor. Right here. Quotient plus remainder over divisor. If they only ask you what the quotient is, that's all you have to write. Just the quotient. If they want to know what's the remainder, tell me the remainder. But if they want to know what you get when you divide this function by this function, you get q of x plus r of x over d of x. Okay. Now again, the first ones that we look at, we're going to look at with polynomial long division. And the process is identical. Whatever is your first term here, like if you were dividing by a 2-digit, I don't think we have any examples with that. No, they just gave you that. So if you were dividing by 41 here, you would try 41 into 3, into 32, into 324, and then you would put everything up above. That's the same process we're going to use with polynomial long division. If you are dealing with a polynomial and you're dividing by a polynomial that is not first degree, with a leading coefficient of 1, you have to do long division. So this is a quadratic we're dividing by. We have to do long division. So what we're going to do is we're going to say, okay, x squared goes into the first term how many times? And now I'm going to rephrase that question and say it differently. What do you multiply x to the second by to get 3x to the 4th? I don't know. That's my question. You just asked me a question back. 3x squared. I don't really care where you put it, but technically you would want to put the 3x squared above the other x squares. Now, also notice we're dividing this polynomial by this polynomial, and notice we went 4, 3, 1 on your powers. That means there was no x squares. You have to put the placeholder just like synthetic division. Got to have the 0x squared in what you're dividing into, because you're going to get x squares.
You don't need to do that for the
Divisor, you do not. Good question. Only for the dividend, what you're dividing into. So notice there's no x squares here. You have to put it in under the quotient symbol. 3x squared, what do I do with it? Multiply it by the divisor. So 3x squared times x squared does in fact give you 3x to the fourth. 3x squared times the negative 3x is negative 9x cubed. And 3x squared times 5 is plus 15x squared. Now you can see why you have to have 0x squared. There'd be no place to put the 15x squared if you didn't. Same reason why when we put an 8 here, you multiplied 8 times the divisor, wrote it down, drew a line, subtracted. We're just mimicking that process. Okay? We know x squared goes into here, 3x squared times this gives you that. And then we draw a line, and here's where your mistakes will begin. And it's these mistakes that you're going to make on long division are absolutely careless. That's for free. The next one, we have to use the stick. I have to do this because I screw this up at a high rate. It's one of my flaws. So I have to remind myself, physically, mentally, you're subtracting here. Because what happens is, on the first one, people say, oh, 3x to the fourth, subtract, you get 0. And then they do negative 5x to the third minus 9x to the third and get negative 14x to the third, and that's wrong. So I have to say, look, it's negative 5x to the third, but I'm subtracting negative, which becomes plus. So 9x to the third minus 5x to the third is 4x to the third. 0x squared minus 15x squared is negative 15x squared, and then I bring down the 4x and the 6. The signs are where you're going to screw it up. You're not going to remember to subtract sometimes when you have pluses and minuses all mixed together in there. So I play this minus this, this minus this, this minus, and I literally touch it with my pencil. And when I don't do that, when I don't put the minus out here to remind myself, I screw it up every time. Now we start over. X squared into 4x cubed. How many times? 4x. So I put plus 4x on the top. I'm going to multiply 4x times the divisor, and I will get 4x cubed minus 12x squared plus 20x. Draw a line and subtract. When you subtract down, the first term disappears. Better. Negative 15 minus a minus becomes plus, so we're going to end up with negative 3x squared. 4x minus 20x, negative 16x, and then I just bring down the minus 6. Check them, see if you're not clear, anything that's confusing. Does it make sense to everybody? Okay, so then we start again. X squared goes into negative 3x squared. How many times? Negative 3. So up on the top, we're going to put minus 3. Minus 3 times x squared is negative 3x squared plus 9x minus 15. Don't forget you're subtracting. When we subtract here, we get nothing. Negative 16x minus 9x. How much is that? Negative 25x. And negative 6 minus a minus 15 would be plus 9. Now, because x squared will not divide evenly into 25x, you're done dividing. And that means that this right here is what? The remainder. What's this called over here?
Divisor.
What's this?
Quotient.
That's your quotient. Okay? So your quotient is 3x squared plus 4x minus 3. Your remainder is negative 25x plus 9. If you wanted to find out what you get when you divide, you would literally write out the quotient, 3x squared plus 4x minus 3, plus the remainder over the divisor, bless you, x squared minus 3x plus 5. But they're really asking you, what they're really asking you for here is to find the quotient. If that's all they want to know, you stop here. If they ask you to divide, this is how you write your answer. Polynomial long division is time consuming, in my opinion, a little bit time consuming. But it is, for me, I just make mistakes with the signs over and over and over again. So I've trained myself to write subtraction and to literally say, look, you're doing this minus this. In my pencil, if you watch me on my desk, I do this minus this. I don't mess around. If you make mistakes on subtracting ever, then you better find a way to avoid it. So I found my way. Just be careful. Okay? Questions on this? This is the answer for the division. That's how we write it. Okay? Now, polynomial long division can be done with a linear component, but it's easier to do synthetically. But we're going to divide x minus 2 into x to the third plus 5x squared minus 7x plus 2. Notice that we went 3, 2, 1 numbers, so I don't need to put any placeholders, and I'm ready to divide. Give this a shot real quick. So some of you can't do this, okay? Some of you didn't get 16. Some of you have no idea what's going on, and you're not asking questions. I don't know what to tell you. I'm here to get you through it, but I can't help you if you don't ask. X goes into x to the third, x squared times. We multiply what's here times this binomial in this case, and you get x cubed minus 2x squared. In long division, we draw a line, and because Mr. Locker is an idiot, he has to put a little subtraction reminder. X cubed minus x cubed, gone. 5x squared minus a minus 2x squared would be plus 7x squared. And then I always bring everybody else down. That's how I do it. Start over. X goes into 7x squared. So many? 7x. So we multiply here and we get 7x squared. 7x times negative 2 minus 14x. Draw a line. Bless you. And then we subtract. 7x squared minus 7x squared gone. Negative 7 minus a minus 14 is a plus 7. Plus 2. X goes into 7x. 7 times. We multiply, we get 7x minus 14. Draw the line. Don't forget you're subtracting. 7x minus 7x, nothing. 2 minus a minus 14 is plus 16. So your quotient, x squared plus 7x plus 7, plus 16 over x minus 2. That's polynomial long division. All right? It's tedious, it's slow, it's just like it was back in 5th grade, pain. What did they teach you back in 5th grade after you got through this long division? Yeah, you did, but you did that before the division. What did they show you after that? How to use a calculator. And then ever since then, you guys are not the best at fractions, right? What's that? You do get the same answer, absolutely.
No, but I did something completely different, but I still got the same answer.
Okay, now you know that I don't really care about the answer. I care that you did this.
Yeah, I know.
So if you're doing something completely different,
But I like screwed up, but then I realized that instead I put x squared over x3. Instead, okay, I guess it's the same.
if you need it to be this, and if you're not this, you need to figure out why. Something completely different sounds to me like we're writing an essay or we're doing a science project. That's completely different. Okay, I want it to be long division. Alright, so all these long divisions. Now, we're going to do synthetic division. And synthetic division, in order for us to do it, it has to be 1x is what you're dividing by, and then a plus or minus something. Okay, it has to be in that form of x plus or minus c or q or whatever you want to put it on. Now, what we're going to divide into okay, we're going to take the 2, the 1, the -8, and the 5. Right? Over here, we're going to divide by the opposite of what's with x, or the value of x that makes this divisor equal to 0. So what would that be? That's what's going to go in the reverse L box over here. Then we're going to have an L box here. Okay? And we're going to do synthetic division. How do we start? Bring the 2 down. Multiply and underneath. And then what? Okay. I got subtract, I got add, I get divide. Can I get a multiply here? What do we do? Can we get this going here? Add or subtract, multiply or divide? Add down. Multiply. 7, add down. Multiply. And -6. Is everybody following that? All right. Ultimately, we want to know what this -16 represents. We didn't do this problem. 2x cubed. We didn't have that. I thought we got that as interesting. This right here is the same as substituting in -3, direct substitution, right? So this would be f of -3 right here. Okay? F of -3 in this function, f of x, is -16. That's what we learned with synthetic division and synthetic substitution a while back.
So when you write your answer, it's the f of -3.
No, I just want you to know that that's what f of, when we get this number here, that's what f of -3 was. Okay? Okay. So what we're we're going to do 2x cubed plus, what was the rest? X squared
Minus 8 plus 12.
Minus
Minus
8x plus 5.
plus 5.
X plus 3.
Oh,
It's good. No, plus 5. It's good.
8x plus 5. And we were dividing by x plus 3, right? So quickly with this, you can just watch. You don't need to copy. You can just watch this stuff. This is going to be 2x squared. 2x squared times x plus 3 is 2x cubed plus 6x squared. When we subtract, we get 0 and negative 5x squared. We get minus 8x plus 5. X into negative 5x squared is minus 5x. And when we multiply negative 5x squared minus 15x, draw a line, we're going to subtract again. So you're going to get 0, 7x plus 5, and x into 7x is going to be a plus 7, and you're going to get 7x plus 21. When you subtract, you're going to get 0 and then negative 16. So this is minus 16 over x plus 3, or plus negative 16 over x plus 3. That's the long division, which, again, is kind of a pain. But see if you can notice what we have here from the synthetic.
Synthetic division, we just find it.
Oh.
That's what this is. What else do you have? Nothing?
You have the same answer on the bottom.
Right here.
Yeah.
This right here is cube of x, the quotient. When you divide p of x by x minus or x plus something. So these numbers right here give you your quotient. This is your remainder, and we can then just transfer this and say, hey, now it gets a little bit tricky. I usually start here. This is constant, x to the first, x to the second. So it's going to be plus 7 minus 5x and 2x squared.
Will it always be like that?
Yep.
The first one's always the first.
Yeah, well, the first one being the one next to the L box. And then how when you go this way tells you how many powers you're going to have.
So you're always going to have the same no matter if you do synthetic division or long division?
We would hope that, right? You wouldn't want to get two different answers.
Yes.
It's just a great little device, this
So you
synthetic
can use
division.
either one.
Well, I'm going to tell you what to use. Now, on this one, you can use either one. But when you're doing this one, you have to do polynomial long division because what you're dividing by is not x plus or minus something. It just doesn't work that way. Okay? So when we do synthetic division, we are going to find a quotient, we're going to find a remainder. And we can give you what you get when you do, this is asking you to divide. What am I going to put in the L box here? Negative 3. And then it's going to be 1, 4, negative 1, negative 1. You guys are going to be so fast at this, you're going to get to that point where you're just making careless mistakes because you're trying to go too fast. So just take your time, go through. I'm still going to make the careless mistakes. It happens. But what this tells you here is that x squared plus x minus 4 plus 1 over x plus 3 is the quotient. Oh, thank you. 11 over x plus 3. That's what you get when you divide. You get a quotient and then the remainder over the divisor. It gets better. It gets better from here. Synthetic division is an incredibly powerful tool. What's that? Well, you can go through and you can look at the process and compare how synthetic and polynomial lawn works, and you're going to see that really what you're doing is the same deal. And if I had more time, I would get into it, but I still want to get into a couple more things here. But again, that's one of those things where I look at it and I go, not how did they do it, but it's just so cool that they did do it. It's just a great tool. So see if you can do this one. Let's have you do this one synthetically. Wait. Yeah, let's do that. Give that a quick shot, Pander. So 4, 5, 2, 2, remainder is 9. So when you write it, 4x squared plus 5x plus 2 plus 9 over x minus 1. Thank you. Now, that's great for division, but it's still just a cool trick at this point. Okay? It's just a cool trick at this point. What we want to know is if you have something like this, how can we graph it if it was a function? And the things that we need to graph it, you already know some of the things you need to graph it. What do we need to know to graph this function? Leading coefficient, degree. If you know those two things, you know the end behavior. Those are the three we've already learned. The other things we need to know are the roots. And we haven't been able to find the roots. But when we're finding the roots, if we could factor this, for example, if we could set it equal to 0 and factor, we could find the roots. Now in this particular case, how do you factor it? You'd have to group it. And you could factor out an x squared, and you'd be left with x minus 3. And a negative 16, you'd be left with x minus 3. And you'd have x minus 3 and x squared minus 16. X minus 3 times x plus 4 and x minus 4. So where are the zeros? So x equals 3 and plus or minus 4. And we know that there's 3 zeros, and we found all of them. Which means when we graph, and this is going to show you the actual graph, we have a 0, that's on x-intercept, at 3, at 4, and at negative 4. We also know that the degree is 3, the leading coefficient is positive, so what do we know about the end behavior?
It's going to be down up.
Down, up. So when we graph from this one, we're going to be down, this one we're going to be up, and we're going to do a wiggle in between. And you can see with that wiggle,
Oh, really? There's a ton of way.
nope.
Well,
Don't worry about the graph right now. I just want you to see why we're doing what we're doing. If you can find the zeros, you can draw the graph. We don't care how high and how low the wiggles go. And we'll talk more about that when we get to the graphing. This is what the factor theorem tells you. If you know a factor, okay, or if you know a solution to a polynomial, you can find the other factors. Okay, given one of the zeros, you can find the other zeros. Because if you know a factor, when you divide it, what's the remainder? If you know something is a factor, when you divide it, what's the remainder? What is it? No. 8 is a factor of 64. What's the remainder when you divide 64 by 8? It is not. Listen to the question. Listen to the question. When you divide 64 by 8, what is the remainder? 0. There is no remainder. It goes in evenly, perfectly, exactly, with no remainder. The same is going to be true when you know, if you know that this is a factor, and you look at this, you say, okay, can I factor by grouping? Yeah, maybe. There's sometimes you can, sometimes you can't. But if x plus 2 is a factor, when you synthetically divide,
Oh.
you had better get a remainder of 0. And when you do this, you get the remainder of 0. This is your other factor. And in this case, it is a quadratic. And you guys are really, really good at factoring quadratics. All right? So you could factor this 3x, x, 4, and it'd be minus and plus 2. So then your other roots are at 4 and negative 2/3. Now again, this one maybe would have worked out where we could have divided out something and it could have been factored by grouping, but it doesn't look like that's going to be the case. If you know this is a factor, you can find the others. Okay, I have a couple things to tie this up, but we're out of time. So let me show you the homework. Is here. It's not number 29. What number are we on? 22. Quiz tomorrow. Leave the homework on the table on your way out.